Good evening, everyone. So welcome to my YouTube channel, Math Section. So today we are going to see another property of a group, that every element in a group has a unique inverse. Okay. So we'll prove it. So let's say its theorem. So this theorem is nothing but uniqueness of inverse. Okay. Uniqueness of inverse. Every element in a group has unique inverse. Okay. So we'll prove it. Let G be a group and A belongs to G. Let B and C are two inverses of A in G. Now, B is inverse of A in G. We have AB is equal to E is equal to B. So this is equation 1. Now, also C is inverse of A in G. We have AC is equal to E, C, A. Now we want to show that the inverse is unique. We have to show that B is equal to C actually. Okay. So what we will do next, B is equal to, can write B, E. Okay. B we can write is nothing but what is the value of E? From equation 1 we can write it AC. From equation 2 we can write the value of C from equation 2. From equation 2. Okay. We have this. But associative property, we have this one. B, we can write like that. Okay. Now, B value is nothing but E. Identity from 1. But E is identity, so it is nothing but C. Because E is identity element. You operate identity element with any element, you will get that element. So this implies B is equal to C. So this implies inverse of A is unique in G. So this implies inverse of an element in a group G in a group is unique. Okay. So this is true. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you very much.